Good morning. So today class we are going to see about 8-point DFT. So already we have seen a 4-point DFT. Same procedure that will be repeated for this 8-point DFT. Look at this. The given problem is correlate 8-point DFT of the sequence x of n equal to 1 1 1 1 0 0 0 0. So totally we have 8 samples, 4 1 and 4 zeros. Look at this 12 factor correlations. So W of 8 will be equal to, so we need to construct from case equal to 0 to 7. Similarly, n equal to 0 to 7. We need to multiply these values and we need to construct this W8 matrix. Look at this. If you take this case equal to 0, so and that should be multiplied with n value 0 to 7. So if you multiply with 0 with anything, you get a 0 only. So that's why this will be W0 of 8 for all, and this also W0 of 8. So here we will get a 1. So 1 into all the values 0, 1, 2, 3. So we need to multiply 0 into 0, that is 1 into 0, 0, 1 into 1, 1, 1 into 2, 1 into 3, 1 into 4, 1 into 5, 1 into 6 and 1 into 7. Here case equal to 2, so 0 into 2 will be 0, 0 into 1, so that will be 2, and 0, that is 1 into 2 will be 4, 6, 8, 10, 12, 14, it will multiply with 2. Here will be 3, so 0, 3, 6, 9, 12, 15, 18, 21. Here 4 no, so 4 into 0, 4 into 1, 4 into 2, 4 into 3, 4 into 4, 4 into 5, 4 into 6, 4 into 7. Here we get a 5, so 4 into, that is a 5 into 0, 5 into 1, so 5 into 0, here 0, 5 into 1 will be 5, 5 into 2, 5 into 3, 5 into 4, 5 into 5, 5 into 6, 5 into 7. So that's why we get this 0, 5, 10, 15, 20, 25, 30, 35 like that. So here also we get a 6. So 6 into zeros. 0, 6, 12, 18, 24, 30, 36, 42. 6 multiples of 6. Here we get a 7. So 0 to 7 we need to multiply it. So 0, 7, 14, 21, 28, 35, 42, 49. So these matrices will be constructed. So again we need to compute individual values. So we already know how to compute it. So use the same methods to compute the W8 of matrix. Look at this. So first one W1 of 8. So for this W9 of 8, W17 of 8, W25 of 8 and W33 of 8, W41 of 8, W49 of 8, all the things we get the same values because that the same value that will be repeats. So actually if you substitute these values, so we get as cos 45 minus j sin 45. So that will be, you get this 1 by root 2 minus j 1 by root 2. Similarly W2 of 8 and W10 of 8. So these values we get as minus j. Similarly for this W3 8, 11 8, 19, 27, 35, 43 we get minus 1 by 2 minus j 1 by root 2. So W4 of 8, W, so these values we get a minus 1. W5, W13, 21, 29, 37, 45 we get minus 1 by root 2 plus j 1 by root 2. So W6, 14, 22 for this we get a plus j. And look at this for this W7 of 8, 15 of 8, so you get a plus 1 by root 2 plus j 1 by root 2. So we take the matrix and multiply with this. So x of 0 to 7, that is a capital X of n. So this is the output frequency domain representation of the signal, that will be equal to W8. So this is the matrix we constructed for, get it from previous things. So that should be multiplied with an input sequence 1 1 1 4 zeros. So these two will be multiplied to get a final answer. So take this 1 and that should be multiplied with 1. So first sample and this first sample. Similarly second, third, 4, 4. So similarly all these 8 samples that should be multiplied with this. This is for first row. For second row we need to take this second row and then that should be multiplied with this value. We get a second row of output matrix. Similarly we need to take this third one and that should be multiplied with this, and then fourth one that should be multiplied with this for a fourth row. Similarly for a fifth row these samples will be taken and that should be multiplied here. Sixth row we need to take these samples and then multiply with this. For last row, seventh row samples should be taken and that should be multiplied with this, and to get a seventh row of output matrix. Look at this multiplied values. Look at this 1 1 1 1 and 1 1 1. So here also we have 4 1 and 4 zeros. So if you multiply it, so this 1 into 1 and second one is also 1 to 1 into 1, third one also 1 into 1, fourth one also 1 into 1. Remaining 4 1 should be multiplied with the zeros. So we get a 4 1 plus 1 plus 1, then we get a 4 1, and then we get a 4 zeros. Look at this, 1 plus 1 plus 1 plus 1 plus 0 plus 0 plus 0. So that will be equal to 0. That is 4. Look at the second one. So first 4 samples should be multiplied with the corresponding input, and then remaining 4, that will be 0, because all the last 4 signals will be 0. Look at this. So 4 signals will be 0. After this 4, always we get a 0, because one sample is 0 means the entire result will be 0 only. Look at this. So first 4 samples that will be multiplied and then added, remaining 4 samples will be 0 0. Similarly, each will we are multiplying it, we get the summation of these results. So look at this. This is the, we need to again add the real part separately and then imaginary part separately to get the final results. So this is the final results for the given input sequence. So we can write it at x of k equal to these 8 samples. This is x of 0, 1, 2, 3, 4, 5, 6 and 7. So this is the output sequences.